Hello. In this video, we're going to go ahead and look at stating the domain of the following rational functions using interval notation. So for letter C here, we have y equals 4 divided by x squared minus 25. The domain comes from the denominator, and the denominator is x squared minus 25. We set that not equal to 0 and solve. I'm going to go ahead and add 25, and then use the square root property. So that means that x is not equal to either plus or minus 5. So what you would see in my math lab would be the set of all x such that x is not equal to negative 5, comma, x is not equal to 5. And that would be in the square there, and there you go. But for me, I would prefer to see it like this. Negative 5 and 5, everything to the left of negative 5, excluding the negative 5, everything between negative 5 and 5, excluding both endpoints, and then everything to the right of 5. So the domain is negative infinity to negative 5, union negative 5 to 5, union 5 to infinity. And there you go. That's letter C. Next, let's look at letter D. The denominator, now notice that these two functions are very similar. Y equals 4 divided by x squared minus 25, and D is y equals 4 divided by x squared plus 25. They're very similar. It's just that one's positive and one's negative. Well, one's plus and one's minus. So take the denominator for letter D, which is x squared plus 25, set it not equal to 0. And then solve it just like we solved the previous one. Except now we have x is not equal to plus or minus the square root of negative 25. So x is not plus or minus 5i. But here's the thing. We're only talking about real numbers for domains, so that means that this 5i does not limit any of the real numbers. So therefore, the domain is all real numbers negative infinity to infinity. The important thing here is to understand that this denominator did limit our domain because this denominator can be 0. This denominator, however, cannot be 0 in the real numbers because the lowest that x squared can ever be is 0, and 0 plus 25 is still 25. So as a result, this denominator is never going to be 0, which is why it has a domain of all real numbers. Alrighty, I'm going to go ahead and end this video here, and I'm going to see you in the next one. Have fun.